Hello students, in this video we are going to study the remaining part of the chapter number 11. The chapter name is Force and Pressure. Class 8, Subject Science, ncert. Before starting that, let me recall what we had seen in the previous videos of this chapter. So in the starting we had seen that a push or a pull on an object is called a force. Then after we had seen how we can represent the force. So the strength of a force is expressed by its magnitude, and with that it is also necessary to express the direction of the force in which it is applying. Then after we had seen that when two forces act on an object in the opposite direction, then the resultant, or you can say net force, is equal to the difference of the applied force, and it is in the direction of the greater force. The effective, or you can say the net force, is in the direction of the greater force. Then we had seen that when two forces act on the object in the same direction, at that time the net force is equal to the sum of the two applied forces, and it is in the direction of any of the force. Then after we had seen that when the direction and or the magnitude of the force changes, the effect of the force is also changed. Then after we had seen the state of motion of an object is described by the speed and the direction of motion, or both, that is speed and the direction of motion. The next we had seen that was an object may be at rest or in motion, so both of these are its state of motion. The force applied brings a change in the state of motion of an object. So that is the effect of force on any object. Next we had seen that the speed of an object increases if the force applied on that object is in the direction of the motion of the object, and the speed of an object decreases if the force applied on the object is in the direction of opposite to that at the motion of the object. That means if we are applying the force in the opposite direction of the motion of the object, so at that time the speed of the object, it will decrease. Then we had seen that the application of the force on an object change its shape, and if the object is not able to move, then at that time it changes the shape of the object. Then we had seen the different types of the forces, that forces can be of two types, that is contact force and non-contact force. The contact force is that force which can come in action only when two objects are in direct physical contact with each other. So that is known as the contact force. Like examples of the contact forces are muscular force, frictional force, and mechanical force. Then after we had seen that the force exerted by the muscles of a body is known as the muscular force, and it is the example of contact force. Next we had seen that the force that opposes the, or which oppose the motion of an object and arise due to, or you can say it come into picture due to the contact between the two surfaces, then it is known as the frictional force. And the force applied by a machine is known as the mechanical force, and these are the examples of the contact forces. Next we had seen that the force act from the distance without coming into direct contact with the object, so that kind of forces are known as the non-contact forces. For example, magnetic force, then after electrostatic force, and gravitational force. In that we had seen that the force exerted or applied by a magnet on another magnet or magnetic material, so that kind of force is known as the magnetic force. Then we had seen that the force exerted by a charged body on another charged body or uncharged body is called an electrostatic force. And we had seen that the every object in the universe attract every other objects towards itself, and this attractive force is called the gravitational force. The force with which the earth attracts the objects towards it is called the force of gravity or gravity. So these are the things we had seen in the last videos of this chapter. So now let we continue with the next topic in this chapter, that is pressure. So in the class 7, you had learned that strong winds during the storm or a cyclone, it can blow away even the rooftops. When there is a storm or cyclone, it can blow away the rooftops of the houses. And you have also learned that the winds and cyclone are caused by the difference in the air pressure. We had seen that if the air pressure difference is there, or the difference is there in the air pressure, then at that time the winds and cyclones are formed. So now is there a question is that is there any relation between the pressure and force? So now let me find out what is the relation between pressure and force and what is pressure. So for that, here one activity is given to you, that try to push, or if you had already, I think you had done this once, try to push a nail into a wooden plank by its head. That means by its head, that is, this one is the head of this nail. So from this head, you have to try to push this nail into the wooden plank. And then you have to answer that, did you succeed? So we know that no, we cannot push the nail into the wooden plank by its head. So now then after try to push this same nail by the pointed end of this nail. This one is the pointed end of the nail. So try to push the nail by this end, and now at this time could you do this or can you fix this nail in the wooden plank? So yes, you can say that from this pointed end you can fix this nail into the wooden plank. So now next another same example is try cutting vegetables with a blunt knife. Blunt knife, that means a knife which do not have any sharp edges. So try to cut the vegetables with such kind of knife, and then after try to cut the vegetables with a sharp knife. So which one is easier? So obviously to cut the vegetable with sharp knife is easier as compared to the blunt knife. So now did you get the feeling that the area over which the force is applied, like in the example of nail and wooden plank, the force is applied on the pointed end, and in the knife it is applied on the sharp edge of the knife. So it plays a role in making this task easier. So yes, when we are applying the force on a particular area, at that time this task becomes the more easier. So that we can say that the force which is acting on a unit area of a surface is called a pressure. So this is the pressure, the force acting on a unit area, acting on the particular area of the surface is known as the pressure. When we are applying the force on the pointed end of the nail, we can say that we are applying pressure on the pointed end of the nail. Same as in the case of the knife. So the force which is acting on a unit area of the surface is known as the pressure, and here the formula for pressure is given to you, that is pressure is equal to force divided by the area on which it is acting or on which it acts. So pressure is equal to force divided by area. So now at this stage we consider only those forces which act perpendicular to the surface on which the pressure is to be computed, or we are going to count the pressure. That means on the object we had seen the many kind of forces are acting together at a time. So some of the forces are also acting on a surface in an angular format, or you can say at some angle. So right now at this level we are going to study about we are going to count only the forces which are acting on the perpendicular to the surface. That means if this one is your surface, then the force which is acting like this perpendicular, those kind of forces we are going to consider right now. Now Paheli is saying something that I now understood why porters place a round piece of cloth on their heads. Porters, that means a person who lifts the loads or luggage, so that is known as the porter. So why he is placing the round piece of cloth on their head? So by doing that, they increase the area of contact of the load with their head. They are trying to increase the area of the contact. So the pressure on their head is reduced and they find it easier to carry the load. here you can see that the person is carrying the load, and on his head the round shape cloth is there, or round cloth is there. But why they are putting this round cloth on their head? Because it increases the surface area of their head, and the pressure, as in the equation we had seen that the pressure is equal to force divided by area. Area is in denominator, so as the denominator will increase, the pressure will reduce. So by increasing the surface area we can reduce the pressure. So that by doing that, this man or this person find it easier to carry the loads. So that's why they are putting the cloth on their head. Now note that the area in the denominator, as we had discussed in the above expression of pressure, is in denominator, area is in denominator. So smaller the area, larger the pressure on the surface of the same force. For the same force, if the force applied is same but the area is smaller, then the applied pressure or the pressure acts on that is larger, and the area is of the pointed end of the nail is so much smaller than that of its head. So that's why we can say that the pressure is high, and because of the high pressure or larger pressure we can easily fix the nail into the wooden plank. So the same force therefore produces the pressure which is sufficient to push the pointed end of the nail into the wooden plank. So that's why while fixing or while pushing the pointed end of the nail in the wooden plank, it is easier because the surface area is reduced and pressure is increased. Now can you explain why shoulder bags are provided with broad straps, or you can say broader parts as compared to the others, or broader strips and not thin straps, and why the tools meant for cutting and piercing always have the sharp edges? So here the same answer is there. The shoulder bags are provided with the broad strap because it will increase the surface area, and at the end it will reduce the pressure. So that's why we can easily carry the goods, or you can say luggage, which is there in the bag. So they are provided with the broader straps. And in the knives, while cutting or piercing, the tool which is used to cut or pierce, they have the sharp edges because it reduces the surface area, and the reduce in the surface area it will increase the pressure. So by the same force we can apply the higher or larger pressure, and we can cut or pierce the objects easily. So that's why they are applied with the, or they are given with the sharp edges. Now this is about solids, that solids objects exerts or they apply the forces. Now what about the liquids and gases? So do liquids and gases also exert pressure, or they are applying the pressure? Does it also depends on the area on which the force is acting? So now let me find out that whether the liquid and gases exerts the pressures or not. So first here next topic is given to you, that is pressure exerted by the liquids and gases. Here one activity is given to you, that is activity number 11.8. For that you require a transparent glass tube or a plastic pipe. Then after, the length of a pipe or tube should be about 25 cm and its diameter should be around 5 to 7.5 cm, and also take a piece of thin sheet of good quality rubber, like you can use the rubber balloon also and rubber sheet also. Then after, stretch the rubber sheet tightly over one end of the pipe and hold the pipe at the middle, keeping it in a vertical position. Like here in the figure it is shown to you. Like this, you have to keep the pipe in the vertical position, and at the bottom you have to fix this rubber balloon or rubber sheet. Then after, ask one of your friend to pour some water in this pipe. Does the rubber sheet bulge out? That means, do you find that this rubber balloon inflated? So yes, you will find that when you pour the water in the pipe, this rubber sheet or rubber balloon will bulge out. Now next is, note also the height of the water column in the pipe. height of the water column, that means the level of the water in this pipe. So you have to note down this height of the water also, or water level also, and then after pour some more water and again observe the bulge in the rubber sheet and the height of the water column in the pipe. After pouring the more water, you have to mark this water level in the pipe and also bulging of this rubber sheet. Then after repeat the same process for few more times, and you have to then answer that can you see any relation between the amount of the bulge in the rubber sheet and the height of the water column in the pipe. So yes, you can say that when we are filling more water in the pipe, the amount of bulges in the rubber sheet, it will increase and as compared to the previous one. So we can see that if you will perform, you will observe that when some amount of water is poured in the transparent pipe which is tied at the end with the rubber band, or you can say rubber sheet, the rubber sheet bulges out, as we had seen in the first case, and the height of the water column in the pipe increases. That means if we are pouring more amount of water, then the bulging of rubber sheet also increases on pouring more amount of water in the pipe. So the bulging of a rubber sheet increases as the height of the water column in the pipe increases. So we can conclude that the pressure which is exerted or applied by a water at the bottom of the container, which we can see, that means here we are applying the pressure, or pressure is exerted over here. So that pressure is proportional to the height of its column. That means if the height of the column, that means water level increase, this pressure will also increase. That means bulging of balloon will increase. So this is by this activity we can say that the water exerts the pressure at the bottom of the container. Now another activity after that is also given to you, that is activity number 11.9. For that you require a plastic bottle, and you can also use the discarded water or soft drink bottle. That means you can use used water bottle or soft drink bottle also. Then after the fix a cylindrical glass tube a few centimeter long near its bottom as shown in the figure. Like here it is shown to you. You have to take the plastic bottle, and at the bottom you have to fix the few centimeter long glass tube near the bottom. Then you can how you will fix this? So you can do so by slightly hitting one end of the glass tube and then quickly inserting it near the bottom of the bottle. You can hit the one end of the glass tube, and then after quickly you can fix this in the plastic bottle, and make sure while doing that there is no leakage or water cannot leak from the joint. And if there is any leakage is there, then seal that with the molten wax. Then after cover the mouth of the glass tube with a rubber sheet, thin rubber sheet, as we had done in the previous activity. That is, you can also use the rubber balloon. Then after fill the bottle up to half with the water, and you have to observe what is happening with this rubber balloon. And why does the rubber sheet fixed to the glass tube bulge this time? That you have to answer, and then after pour some more water in the bottle, and again you have to observe the bulges in the rubber sheet. Is there any change in the bulges of this rubber sheet or not? So if you will perform this activity, you will find that when some amount of water is poured in the bottle, that means for first condition, the rubber sheet bulges out, and this shows that the liquid exerts the pressure on the wall of the container. Why? Because we are fixing this rubber tube, or you can say glass tube, on the wall of the container, so that we can say that the liquid also exerts the pressure on the walls of the container. And on adding more water in the bottle, the bulging of the rubber sheet increases. If we are adding more water, then this bulging will also increase, and that shows that the pressure which is exerted by the water on the wall increases. So we can say that the liquid in the container exerts the pressure on the walls of the container, and the pressure which is exerted by liquid on the walls of its container increases proportionally as the height of the liquid column from the bottom increases. If we add more amount of water, then the bulging will increase, and if we will not add the water, or if we will reduce the amount of water, then again the bulging will reduce or it will decrease. So from this activity, note that the rubber band sheet has been fixed on the side of the container and do not at the bottom. And does the bulging of the rubber sheet in this case indicates that the water exerts the pressure on the sides of the container as well. So yes, that we had already discussed that the water exerts the pressure on the bottom of the container as well as on the sides of the containers too. So now here one another activity is given to you, that what amount of pressure is working or it is exerting on the walls of the container. So for that, next activity number 10 is given to you. So for that you require an empty plastic bottle or a cylindrical cylinder, and then after you can also take a used tin can or a used plastic bottle. You have to take the cylindrical bottle, you can use the used plastic bottle or tin can also. Then after drill out 4 holes all around near the bottom of the bottle and make sure at that time that the holes are at the same height from the bottom. Here in the figure it is shown to you. You have to make the 4 holes from 4 sides and you have to make sure that these holes are at the same height from the bottom. And then after fill the bottle with water and you have to observe what is happening with the bottle. So do the different streams of water coming out of the holes falls at the same distance from the bottle, and what does this indicates? That you have to answer. So if you will perform this activity, you will find that 4 different streams of water coming out from the 4 holes which are at the same height from the bottom of the bottle. That means this one is the water stream. So these 4 are coming out from the holes which we had made earlier, and the water coming out from all the holes falls at the same distance from the base of the bottle. That means this distance is equal to this distance. At the same distance these falls are falling down, or the streams are falling down. So that's why we can say that the streams of water coming out from all the 4 holes fall at the same distance from the bottom of the bottle. So this indicates that the liquid exerts the pressure equally at the same depth from the open surface of the liquid. That means at the same height we are making the holes. So that's why the pressure or the amount of pressure is also the same. So now can you say that the liquid exerts the pressure on the walls of the container? So yes, the liquid exerts the pressures on the wall of the container. And do gases also exert the, now question is this is about liquid. Now what about the gases? So do gases also exert the pressure, and do they also exert the pressure on the walls of their containers? So now let me find out through some examples. Before that, here Bujo is saying something, that I have seen fountains of water coming out of the leaking joint or holes in the pipe which is supplying the water. So now is it not due to the pressure which is exerted by water on the walls of the pipes? So yes, it is because of the pressure which is exerted by the water in the walls of the pipe, on the walls of the pipes. So that's why you can see the fountains of the water. So now what about the air? So when you inflate a balloon, why do you have to close its mouth? So to prevent the escaping of the air from the balloon, we have to close the mouth of the balloon. Then what happens when you open the mouth of an inflated balloon? So we can say that the air will blown out. So suppose now you have a balloon which have hole. So now would you able to inflate the balloon? So no, if the balloon has the hole, we cannot inflate the balloon, or we cannot fill the water, we cannot fill the air in the balloon. So now can we say that the air exerts the pressure in all the direction? So yes, when we are filling the air in the balloon inflated, so that's why we can say that the air also exerts the pressure in all the direction. Do you recall what happens to the air in the bicycle tube when it has a puncture? That means it has the hole. Do this observation suggest that the air exerts the pressures in the inner walls of the inflated balloon or a tube? When there is a puncture in the bicycle tire, then we are not able to ride the bicycle because the air which is exerting the pressure on the rubber tube is not there. So we can say that the air exerts the pressure in the inner wall of the balloon or as well as tube. So we find that the gases also exerts the pressure on the walls of their container. So by this we can say that all the substance, that means liquid, gaseous or solid, they exert the pressure. So now next is atmospheric pressure, which is exerted by the air, atmospheric air. So you know that there is the air all around us. So this envelope of air, or you can say cover of air, is known as the atmosphere. That is known as the atmosphere, and this atmosphere air extended up to many kilometers above the surface of the earth. We know that the atmosphere is extended up to the many kilometers above the surface of the earth, and the pressure which is exerted by this air is known as the atmospheric pressure. So now what is the atmospheric pressure? So the pressure which is exerted by the atmospheric air is known as the atmospheric pressure. We know that the pressure is the force per unit area. We had seen that the pressure, that means the force per unit area. So now imagine a unit area and a very long cylinder standing on it, and it is filled with the air. So then the force of gravity on the air in the cylinder is the atmospheric pressure. Here you can see the atmospheric pressure is the force of gravity on the air in a column of a unit area. Here this cylinder has the unit area, and in that the air is filled, and we know that the force of gravity is there, or it is acting on the each and every object. So it also acts on the air particles. So the air which is filled in the cylinder, they also has the gravity force, or on that the gravity force is working. So the gravity force which is acting on this air column is known as the atmospheric pressure. But now the question is, how large or small is this atmospheric pressure? So now let we get an idea about how large this atmospheric pressure, or what is the magnitude of this atmospheric pressure. So here one another activity is given to you, that is activity number 11.11. So for that you require a good quality rubber sucker. If you had seen, it looks like a rubber cup. Here it is shown to you. You may find this at the bottom of any of the tripod stand, or you can say teapoy. So, and on that at the end this kind of rubber sucker are there. So then after you have to press it hard on the smooth plane surface. So and then you have to answer that does it stick to that surface, and then after try to pull it off this surface, and you have to answer that can you do it easily or not. So if you had tried this if you had tried to fix the rubber sucker on this plane surface, so when this rubber sucker is pressed hard on the smooth plane surface, it sticks to this surface, and then after it is not possible to pull this sucker off this surface, or to remove this sucker from this surface. So let me see what happens when we are pressing this rubber sucker on the surface. So when you press this sucker, most of the air which is there in between the cups, that means suckers, and the surface, that air escapes out, and the sucker sticks to the surface because the pressure on the atmosphere which is act on that sucker. So to pull the sucker of the surface, the applied force should be larger enough to overcome the atmospheric pressure. The atmospheric pressure is there on the rubber suckers, so that's why we have to apply that much force or that much pressure which nullifies, or you can say which overcomes the atmospheric pressure. So this activity by this activity you might get the idea about the magnitude of atmospheric pressure. And in the fact, it would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. In that we had seen that when we are pressing the sucker on the surface, the air is escaping out. So if there is no air is left in there between these two surfaces, then for any of the human being it is not possible to sucker off this rubber surface, or to separate this rubber surface and plane surface. So now does it give you an idea about how large the atmospheric pressure is? So let we see the value by valuic value. Here Bujo is saying something that if the area of my head were 15 by 15, that means 15 centimeter cross 15 centimeter, then how much force air will exert on his face or on his head. So here in the picture it is given to you that on area of your head, the air column is there, and in that air column, the pressure which is exerted by air is known as the atmospheric pressure. So the force due to the air in a column of the height of the atmosphere and the area 15 centimeter by 15 centimeter is nearly equal to the force of gravity on an object of mass 225 kilogram. That means if your area of your head is 15 centimeter by 15 centimeter, then the atmospheric pressure on your head is equal to the gravity force which is acting on any object, which object has the mass of 225 kilogram. So that much of atmospheric pressure is acting on you. So now you can imagine what amount of, or what is the magnitude of atmospheric pressure. This 225 kilogram can be represented by 2250 Newton. Here N represents the unit of force which is known as the Newton, and it is denoted by the capital N. The reason now we are not crushed under this force of gravity is that the pressure inside our body is also equal to the atmospheric pressure, and it balances the pressure from outside. Now you might have the question that this much amount of atmospheric pressure is exerting on us, so does it not harmful to us, or why does it can't crush us? So the same amount of force is acting in our body, or you can say pressure is there inside our body which equal to the atmospheric pressure, and at the end it balances the pressure from the outside. So that's why we are not get harm from this atmospheric pressure. So this is that our chapter number 11, force and pressure. Here one fact is given to you. The Otto von Guericke, a German scientist, the name is there Otto von Guericke. The German scientist in 17th century invented a pump to extract the air out of a vessel. To extract the air, that means to remove the air out of the vessel. He invented such kind of pump. So with the help of this pump, he demonstrated dramatically the force of air pressure. And in the demonstration of this pump, he shows the force of the air pressure. For that he joined two hollow metallic hemisphere of 51 centimeter diameter each and pumped air out of them. For that he joined these two hemisphere, that means half sphere, with each other, and from in between them, from this whole sphere, he extract out, or you can say he removed the air from in between these two hemisphere, and then he employed the 8 horses on each of the hemisphere to pull them apart. Here in the picture you can see that he attached these 8 horses on both of the side of this hemisphere, and he tried to separate, or you can say he tried to detach these two hemisphere. So great is the force of the air pressure is that the hemisphere could not be pulled apart. But the air pressure was such a great magnitude that this hemisphere could not be separated. So this is the great magnitude of the atmospheric pressure, or you can say air pressure. So this is about atmospheric pressure. So here our chapter gets over. Here are the hard words for this chapters are given to you. You have to write these hard words in your notebook. That is atmospheric pressure, contact force, electrostatic force, force, friction. Next one is gravitational force, gravity, magnetic force, muscular force. Then after next one is non-contact force, pressure, pull and push. So these are the hard words for this chapter. Before ending the video, let me quickly see the summary of this chapter. So force, we had seen that the force could be push or a pull, and a force arises due to the interaction between two objects. The force has magnitude as well as it also has the direction, and a change in the speed of any object or the direction of the motion or both, that means it implies the change in the state of its motion. And then we had seen that the force acting on an object may cause a change in its state of motion or a change in its shape. Then after we had seen that the force can act on an object with or without being in contact with that object. And the force per unit area is known as the pressure, and like the solid also, liquids and gases exert the pressure on the walls of their containers, and the pressure which is exerted by the air around us is known as the atmospheric pressure. So these are the things we had seen in this chapter. In the next video, we are going to solve the textbook exercise for this chapter. Thank you.